Hello everyone, thank you very much for being here with me today. We start a new marathon on JPA and Hibernate. I hope you are looking forward for this. We're going to discuss from the very beginning a lot of things, of course. Probably we won't be able to touch absolutely everything about Hibernate and JPA because, well, you already know that I have a playlist out there which is many hours already in with the content about Hibernate and JPA, so we don't expect to be able to do this in a whole session, but I hope that I can still take the most important things from the very beginning and discuss them together with you. And of course, in case you have questions, you have a live chat there. I can already see your messages in the live chat, and please do leave your messages, questions, discussions, everything you want. And in case you didn't catch the live event, no worries, you can still put your questions and comments in the comment section. And of course, you can always find me on LinkedIn, Twitter, and other social media as well. With that being said, let me actually share my screen because I think you are more interested in code than you are in my face, and we can start with the discussion from the very beginning. So we this way can make sure that if you have any gaps in your knowledge, you will be able to cover them. I'm going to start with only simple projects that don't include any application framework like Spring or something like that. Remember that Hibernate is a JPA implementation, and it's independent to any other framework, application framework, so you can use it together with or without. Now, my recommendation for everyone is to first make sure they understand properly how these frameworks individually works, and only then try to work with it together with other frameworks, like for example Spring. So as an example, if you use Spring Data JPA, okay, and you don't know how Spring works behind the scenes, you will make mistakes. Yes, you will make mistakes. No, it's not possible you will make mistakes, because not knowing what's behind the scenes and working with something abstract above, it's very unlikely you will not run into trouble. So one of the main things I advise you as a developer is to properly know what's behind the scenes of your framework. And that's why I always, when I learn something, I always start with the vanilla stuff. I learn that vanilla stuff, and then I understand properly how it integrates with other things. So don't try to understand working with abstractizations over Hibernate without knowing properly Hibernate. Well, of course, even knowing Hibernate and JPA stuff vanilla is still difficult. You can't say you know it all. I don't know it all. Maybe I've learned some stuff and I forgot it, because, well, it's a lot and I'm only human. And yeah, it's normal to forget when you don't use stuff, but there are essential things like part of the mappings of the entities, the relationships, the JPQL queries, using criteria query, which are essential. You don't need to know all the details. No one says you need to know all the methods and how they work, all the classes. That would make a robot out of you, but you need to understand properly the core so that you can then use it use it well. So in this project that I have started here, I have just added a plain main class, and I have a POM XML file, and you can see here that I only include 3 dependencies. So that's why I started by saying we work with JPA Hibernate Vanilla, not with Spring Data JPA, not with Micronaut, not with Quarkus, not with anything else that can do stuff above Hibernate, because otherwise we discuss that stuff, and normally when you discuss that stuff, you assume you already know Hibernate, okay? But if you know this stuff, then you will be able to work with Spring Data JPA as well. Now, if you, of course, will need more details than we'll be able to discuss in this live session, I do recommend you use the playlist I have created out there on this channel, which is free for everyone, and it has already like 16 lessons or something like that. So please do find all the details there, and never rely only on a source of truth. You have also plenty of books probably out there on Spring Data, JPA and Hibernate Vanilla and so on. Do use those as well. So you can see basically I'm using the Hibernate core, and since I will be using a MySQL local server, I have added my MySQL dependency. You can see I have already a demo here, database schema with only a table called books that has 2 columns. So we will work on simplistic examples, because then I want you to focus on what's important, not on like a table having 7 columns, because that's not essential. And then of course we will work on several other things once we progress throughout this event. So one of the things that I was observing just when I was putting up this example, because I've copied this dependency from an older example I had, is that this dependency has a CVE, which means it has a security issue. Now, of course, it works for our example, but I wouldn't use that in a real world application. What I wanted to mention here beyond our discussion is that always when you use something in production apps, make sure that they don't have CVEs, and if they do have, understand how those CVEs impact your organization, because reported CVEs usually are serious security related problems which you don't want to have in your apps. So yes, I am using now, say, this version of MySQL having a CVE, and this gave me also the opportunity to tell you about CVEs, but when you work with real world applications, if any of your dependencies have a CVE reported, make sure you upgrade it to a version that is secure, or replace it with something else, and understand how that impacts, or maybe already have impacted, your organization. You might have ended already up being hacked by someone, depending on how powerful the vulnerability is. And then of course I will need to use a data source. So data source, it's an object managing connections. If you have started, and normally in this discussion, because it's already an intermediate level discussion, I do assume that you already have used JDBC, vanilla JDBC from the JDK, and you might know that the most simplistic way in which you can connect to a relational database is by using the driver manager class, and say driver manager get connection, and then making sure that you have the JDBC driver in your class path. You will be able to obtain a connection. But normally, if you're already watching this marathon, you probably already know that getting connections and closing them every time you execute a query is not the most performant way of working with a relational database management system, and that's why we have this very important, this essential objects named data sources that help us manage connections. So that's basically what we do with the data source. We will need it to have a management of the data source, so that we don't have to manage the connections ourselves. And of course, Hibernate and any JPA implementation knows how to use any proper data source, meaning any implementation that fulfills correctly the data source interface. The data source interface from the Java SQL package being the one that describes how a data source should look like for a Java application. So let me see some of your comments here while I'm saying hello as well, and I'm trying to read now the discussions, so see if you have already questions. So is it worth it to learn a lot about Java concurrency before starting learning JPA? I would say not. I'm not sure if it's a high link between Java concurrency and JPA. I see them as complementary but unrelated topics, so you can learn them in any order you like. So you can start learning JPA without necessarily working on concurrency first. So when I work with Spring and JPA, Hibernate, yes, because we know Spring Boot uses Hibernate as the convention implementation for JPA. Inside the Spring transaction, sometimes I get a detached entity passes to persist. See, that's what I was saying. So when you work with Spring Data JPA, but you don't know how JPA works behind the scenes, you might end up with situations like, for example, getting a detached entity from the context, and you have no idea what that is. No, well, it's not that difficult actually, because a detached entity simply means somehow it got outside of the context. The philosophy of a JPA implementation behind the scenes is that it uses this context, and many developers starting already using it through Spring Data JPA cannot have or don't have that correct ORM mentality, understanding that they don't work directly with the database but with the context. So sometimes what they do is they operate on the context, they detach an entity and then they try to persist it, and that's exactly what you get when you do that, because the JPA implementation cannot persist, for example, cannot execute an operation on something that has been detached out of the context. So that's why I always say it's important you understand how the thing behind the scenes work before you go into the Spring Data JPA. And at the moment, I see, I won't try to exaggerate things, but it's more than 50% of the developers I see working with Spring Data JPA make a lot of mistakes in their code. Sometimes I do, as a consultant, see and I try to research on the code of a specific organization for giving them different advice, and I see a lot of mistakes on how Spring Data JPA is used. And I do reckon that those mistakes are because of lack of knowledge of the Java developers. So, for example, if they were part of my team, I wouldn't have approved their pull requests, to put it in a polite way. I always find difficult to understand where the error comes from. Well, I did try to explain a bit, but of course, going through the playlist, I think it would be even better if you try it. And the relationship attributes of the relationship cascade, etc. Okay, thanks for the marathon. Thank you also for being here with me. Are you working with Gradle in your projects? Well, I didn't work so much with Gradle in my projects, to be honest with you. Even if Gradle has been lately made the convention by Spring Boot, or at least not by Spring Boot, but through the Spring Boot initializer, I did see still more than 90% of the project I've been consulting using Maven. So I don't think Gradle is a bad tool. I think Maven seems to be more than enough for the majority. I think that's how I would describe it. So a majority wouldn't go to Gradle just because they find Maven as being more than enough for a build tool, more than enough for what they need. And to be honest with you, more than using dependencies, some plugins for your CI/CD, and of course the parents in case of a multi-modular project, I didn't see people needing more than that. And it's not like you work on Maven very often when you work on a project, because, well, Maven is just your build tool. No, it's not what you implement in the end, so it's not your first focus as a developer. Will you also depict the eager and fetch lazy type initialization types? Not sure if I understood the question. We can use lazy and eager, of course. We know there are some defaults based on the type. Maybe that's what you meant. Yes, we will go through that. If it's something else, I might have understood it wrongly. Okay, so with that being said, thanks again. Leave your discussions in the live chat. I will take an eye. I'm always keeping an eye on the live chat. I cannot always, of course, interrupt and answer them, but I hope with the very beginning we understood why I'm using these dependencies. And then you still have so besides the empty main and the POM XML that I have just explained here, you have the persistence XML file. Now I'm gonna tell you that this is the older way in which one would create a connection through what we will soon call an entity manager factory. So I want to today describe you both options, so the programmatic option and the descriptive option for creating, for establishing the configuration of and connection of your application to a database management system. I'm gonna start in the chronological order, let's put it like that. I'm gonna start with the oldest option, which is describing your configuration through XML. You potentially still see this with older projects, so that's why I wanna show you this, and then we can go on and we can use the programmatic approach as well, where we'll use the persistent unit info interface to describe basically the same thing that we are describing here. So that's basically it. Okay, that's what we are gonna start with. So if normally before starting with this, I need to make sure that I have a schema, and I have already shown you that we do have a schema called demo here, and with a table books which contains already some data. So just some stuff to begin with, or to begin working with. And I need to give a name. It has to be a unique name. I have multiple persistent units, so you can see that the structure of this file is that it starts with the root called persistence, and then of course it uses some schema here for validation. This is as described in the JPA specification, and one thing that I haven't said from the very beginning is that the marathon is called JPA/Hibernate, because what we are going to do here is that we are going to use Hibernate as a JPA implementation. JPA, that stands from Java Persistence API, uses it's a specification that has multiple, or may have multiple implementation, has actually multiple implementations. One of the implementations is Hibernate. So Hibernate, we can say it's an ORM framework that fulfills correctly the JPA specification, and this is not the only one. You have other options out there like Eclipse Link or ORM Lite, for example. They do fulfill as well the JPA specification, but as far as all of us probably are aware of, the Hibernate is the convention nowadays, most used of the JPA's implementations, and I figure out that this would be the most useful for you if you learn it further. So how does this the rest of this configuration XML look like? So it has a unique name, and then it has a transaction type. So this transaction type depends on how you want to use your database operations. The resource local is the transaction type you use when you don't have a container covering, let's say, your application with the inversion of control principle. If you simply have an application like I do here, a plain application, no other framework, no other container, then you use what is called the resource local transaction type. But in case you want to have a container, such as for example you were using in the past, like JBoss, Wildfly, I don't know, Glassfish and so on, you needed to allow somehow the container to manage the transactions for you, and then what you would need to use in that case is JTA. I'm not gonna go in a lot of details about that because it's something too old for me to remember, and probably in most cases unnecessary for you. So let's just go with the resource local, which means our applications manages the transactions, as you will see in the examples that follow. And then we do have a set of properties here And in the set of properties, a minimum properties that you have to put here are the driver main class, which means depending on what JDBC driver you use. I'm using the MySQL driver, so I have this main class of the driver, so I have to put it here. And then of course the connections for the URL to my database. So my database was named demo. And that's JDBC MySQL localhost because it's on the local machine. I skipped over the port, which is 3306 for MySQL, but being I'm using the default, I can skip over it. And then the name of the schema I'm trying to connect to, and then the credentials, meaning the username and the password I'm using to connect to. As you can see, I have a very strong set of credentials for my local environment, not root with without the password. Remember, never do that in a real world, never do that in a real world application. And remember, so not only that, you shouldn't give access to your root in a real world application to an application. You never have to put your credentials directly into a properties file. So always use a vault for that, so extracts from somewhere secure the credentials such that they are never exposed and accessible to all your developers or to everyone who have access to your Git repository. And remember that pasting something secret into a Git repository makes it forever, because well, you cannot simply delete something from Git, do you? So it's already put there, you delete it, it's already somewhere in the history. It's very tricky when you put something secret in your Git repository, so in your Salvation repository, management repository. So that's the minimum, but of course you can use different other properties. So for example, you can instruct Hibernate to allow creating your schema directly from the code, which is something that I will teach you never to do in a real world app, but it's something that is very handful when you have demonstrations, examples and tutorials, because it allows you save time. You usually want to avoid having to write the DDL scripts yourself. You can use properties to print the native queries generated behind the scenes. One of the most difficult things about Hibernate and ORMs in general, when you use a framework that abstracts over JDBC, one of the biggest problems, of course, is that you are insecure on which are the native queries generated behind the scenes. So you can't always bet on how and what exactly will be generated, and that's why sometimes through design mistakes, developers can end up with different issues like n+1 query problems or unneeded updates. n+1 query problems, as we will see, it's a problem where due to lack of a correct join, you end up with executing a lot of queries on the database due to a relationship, a lazy relationship, and an incorrect joining strategy. All these problems appear not because necessarily of lack of experience. Even the most experienced developers may have issues with that, and my recommendation always was whenever you finish a feature or simply a correction on something related to the persistent layer and connecting to your persistent layer through Hibernate, make sure you run your application and either execute it with a property showing you the SQL behind the scenes created, or use a profiler. Use a mean that gives you the possibility to see what native queries have been created behind the scenes, and that's because only that way you will be sure that what you've created is okay. And remember that some of the things are not really testable in terms of how they work, functionality. They simply create non-functional issues, and those may be difficult to find in a test environment. So that's why I frequently saw this kind of mistakes going to production. So let me try to create a first connection. So I'm going just to go here to the main class and create an entity manager factory. Now there are different approaches in case we are using a descriptive way like persistence XML to the main itself. Entity manager factory is basically what we want to create first. This entity manager factory is an object that will allow us to create entity managers. Entity managers are the instances managing the operations on the context. So I will explain later. I'm first going to write the code and then I'm going to explain, and I want you to imagine how this works behind the scenes. So this is how you create this. Persistence is the class, and then you have this static method called create entity manager factory, and you have to make sure that your that your persistence XML file is in the resources meta-inf location, and that the resources is part of the class path, which is normally out of the box with a Maven or Gradle project. So normally you shouldn't be doubtful about that. I'm gonna just copy this exactly as is, and I'm putting it here. Okay, and then I'm able to create an entity manager using the factory. And normally both of these should be closed at the end. So what I'm gonna do is I'm gonna catch this exception. Well, I'm gonna use a print stack trace, but normally you should use a locking framework. Always keep that in mind. And yeah, the entity manager and the entity manager factory should be closed once you've finished using them. So like that, they have this close method. I cannot use the try with resources because they are not made as Java resources. So that means they do not implement the auto-closable interface. Otherwise, they would be directly usable in the try with resources syntax. So I have to use a finally block for that. But remember, if ever you will have to use this directly, then these two objects need to be closed when you finished working with them. So that's a good practice that I want you to follow. And what am I doing here? So I'm just gonna do it like this. So I'm gonna start a transaction and I'm gonna end the transaction, and the transaction can end with rollback or commit. So usually if you want to roll back the operations, you call the rollback method. If you want to commit them to make them persistent, you use the commit method here. So one thing you can do is use the rollback in case you have an exception like I did this way. But remember, this is not clean coding or something, so don't take this as an example on exactly how you should write your code, because here I'm using this code as simplistic as possible, just to teach you the most important things about our specific subject. So it's not like everything that I will write here is exactly the way I would write it in a real world application. So be aware of that, and don't take this code as a clean exactly the shape in which you could copy paste it to your apps, because then it will be not the right way. So begin commit, and then of course we need to do something. So that's the problem. What we made here is we connected to the database, we started a transaction, we committed or rollbacked it, and we closed the objects that manage what we need. I can run it normally. If everything is right, I shouldn't have any exception, but it does not do anything, because as you can see, we didn't put anything between the begin and the commit. And the reason is you cannot simply just put something there. You first need to describe how your domain model looks like, and we do that through entities. So the next step for us will be to represent, to model the way our tables from the database look like through entity classes. But I'm starting it. I will let it compile. I'm gonna make sure that this works, and then I'm gonna create a first entity, and I'm gonna show a first operation. So you can see it looks like it worked fine. I mean, all these red logs you see here, they are just coming out from our JPA implementation from Hibernate. It also tells us, hey, you are using an old main class for your driver. Nice thing, no? Normally, so it says, hey, use this instead of what you are using. So that normally means I should go here, and instead of this, I should use that. And I actually knew that, but I'm so old that I'm used with the old class. And then you can see that nothing specific happened. It connected to our database, and then it closed everything, cleaning up the resources that we have created. So I changed that. I want to run it again to make sure that it works and I have the right dependency working with that before continuing. And then the next thing is we are gonna go and understand what the context is, what an entity is, why do we need entities, which is the philosophy that we are using when using JPA implementation, or I would say this can apply to an ORM in general. So you see that it worked and our warning message disappeared because now I'm using the right thing. Good, happy. So going back, I have a simple schema and the books tables. What I'm gonna do, I have to represent every table representing an entity with a class. And when I'm saying every table representing an entity, remember that in a database you have two kinds of tables. Some of them are representing entities, and other tables, they are simply join tables. In JPA, so in your Java application, only the entities will end up with classes. The join tables don't need their classes, and your JPA implementation knows how to use them behind the scenes. So I can just go back here. Oh, this is mine. And I'm gonna create an entities package. And in the entities package, I'm going to create a book class. And one thing that you might see is that the book class is for the books table. So the name of the table is not exactly the one-to-one with the name of my class, but that's normal because in many cases you will end up with having tables using this particular plural form of the entity, while in Java we know that names of classes are not using plural, so they will always be like book, author, shop, so on and so forth, whatever you have their product. So one thing we do is we make sure we describe this as an entity, and you do that by using the entity annotation above. This is probably the most important thing you have to do, is using the entity annotation. And you can see that this has been imported from the Jakarta persistent package, which in the past would have been Java X persistence. So somewhere in 2019, I think, this Jakarta changed to a Java X when the Java EE has been outsourced by Oracle to the Eclipse Foundation, and then due to legal stuff they had to change the name from Java something into something else, and Jakarta has been chosen as the new name for Java EE. So now it's called Jakarta EE, but that's how it evolved. That's the evolution of the framework. So the change of the naming is just mainly because of legal stuff. And then when you create entities, if the name of the class doesn't match exactly the name of the table in the schema for which you create that class, the JPA implementation will not know how to find that table, won't be able to understand that your class has been created for the books table because it's not exactly the same name. So that's why in many cases the entity annotation will always be followed and used together with a table annotation, which is also similarly from the Jakarta persistent table, and this is used to specify which is the name of the table to which this entity applies. And now you see that IntelliJ is a very smart IDE, and it continues to underline with a red line the name of the class, making me aware of something that is not correct with my entity. And if you go over it, you will see that it tells you that the entity should have a primary key. One essential thing to remember is that in JPA, a class an entity always needs to have a primary key, which we also call an ID. While in most cases in the database itself you will have a primary key, so like in my case here the ID is the primary key. Many database technologies allow you creating tables without a primary key, including MySQL. So if I want to create a table without a primary key here, I am able to do that. Same is with Oracle, same is with Postgres. So what do we do in such a corner case where we have the situation where there is no primary key defined at the database level? Because there might be such corner case situations. Yes, I know it's normally there are not all of them, but there might be. In that case, you either find one column that can be used as a primary key, meaning that it ensures the unicity of the value per instance, per record, or you have to find a combination of columns if one of them doesn't ensure you uniqueness. And for a combination of columns, you use composite primary keys, and these are supported. So either way, you need to end up with having a primary key somehow. There is no JPA entity without an ID. Fortunately for us, for this example, it's simple because I only need to add, let's try to use the wrapper class, no? And I only need to add the ID, which is defined primary key. So for me, it's only a matter of using the ID annotation, and see, once I have used this, the error disappeared. Now, more than that, you might have a situation like it happens in many cases, for example, where this value is generated somehow. It might be generated via auto increment, which I think is the case here for me. Let me see, how do I see that? I do remember I have done that. Maybe if I do this outer table. Just a bit slower, but anyway, probably it's auto increment. Yeah, you can see it here. No, so my ID, not only it has been defined as a primary key and not null, which is normal, it's also auto increment, which means that I have selected a value generation strategy from the DBMS level. So what you can do if you want to specify that you have a strategy for generating the value and that you don't manually put it through the Java application, you use this generated value annotation, and then you have to fill out the strategy you use. So there are a few strategies you can use with the latest JPA specification. Identity is the one that we are using if we have used auto increment, but then there is also the possibility to use a sequence for generating the values, a table, or simply generate them as universally unique identifiers, which is a common technique for tables with a very large number of values distributed, potentially distributed throughout multiple availability zones. So such as cases as, for example, transactions of a bank and stuff like that. Now I'm going to use the identity, but as an idea, so identity is what we apply when we have an auto increment at the database level. Sequence, if you use a database sequence to generate the values, and then you have to provide the name of the sequence as well. Very often used together with Oracle databases. A table is somehow a default strategy that uses a separate table at the database level to generate the values. A very hard to find this strategy in the real world. It's not something that you necessarily want to use, because in most cases you either use identity, sequence, or UUID. Naturally, the advantage of table is that it works in any database, because any database is able to create a table. So it's not like identity that where there are databases that don't support auto increment, or sequence where there are databases that don't support sequences. Tables are the thing that can't miss in any relational DBMS, no? So that's why you can use it everywhere. However, the performance with a table for generating the values is very poor, because always generating a new value needs to lock that table, and usually tables are not as structures in the database. They are not defined for such kinds of operations. And of course UUIDs in case you want to create it as UUIDs. I'm gonna put it as identity, which fits exactly the definition of my table, and then I'm gonna add the see that it's basically the title, which is a string. A varchar of 255 can be defined as a string. So for me here is private string title, the book's title, and then I'm gonna just create the getters and the setters for this like that. And this is the minimum I need for an entity. And I can use it now. How? For example, if I want to find an entity by its ID. Now let's say we know we have an entity with the ID 3, for example, my troubleshooting Java. No, I'm just gonna go here and I'm using one of the operations of the entity manager, which is called find, and I'm gonna say just I want to find the book with the ID 3, and I have to import the book class, of course. Yeah, be careful where you import it from. It should be our book entity here, and then you say book B, and let's print it. CB1 system out. And if I want to do something like that, yeah, normally I need to also define a toString inside just to see it easier. So I'm gonna print the ID and the title. And let's run that, see what happens. Oh, still building. Meanwhile, what you think about Spring Data JDBC? My bet is Juke. Is that better than Hibernate? Better no, alternatives yes. Remember, any technology has advantages and disadvantages. The role of a software architect is to find out the compromises and choose wisely the best technology for the case. So there are technologies where simply JPA doesn't work, okay? Where you don't want to use JPA. I'm gonna explain some of the conditions here. Spring Data JDBC is a very good alternative where you want to have an abstraction over straight JDBC, for example. Juke is also a very interesting ORM that helps you connect to your persistent layer, which in some cases is much better than using JPA. But again, it always depends on the context. The way you choose the technology depends a lot on the context. So I ran it. I did run my my application, and you can see that indeed I found and printed in the console the book that has the ID 3, and the title has been found in the database. Cool. So that concludes with our first example, but I want to do a little bit more than that. So I would like to now change my example so that instead of using a descriptive way for getting the entity manager factory, the persistent unit basically, because the persistent unit is how we name the set of configurations that define an entity manager factory. I want to programmatically create this. And for my second example, I'm gonna just comment out this, and I'm gonna try to find a way to implement an entity manager factory programmatically, so to get it not by the means of a persistence XML file, but by the means of Java code inside your app. Because if you use Spring data JPA, for example, application, you will never see a persistence XML file. You will just add your properties in the application properties or application YAML file, and somehow they will magically be transformed into the entity manager factory behind the scenes. And then you might wonder, okay, how does that really work? I mean, no, isn't that a good question? How the heck does Spring Boot connect to create an entity manager factory without having a persistence XML file at all? Because if you consider that this persistence XML is the entry point of the entity manager factory, then this means that you will always need to have it, which is not the case. And every one of us who have used a Spring Boot application with Spring Data JPA have seen that there is no hidden persistence XML file there that your app uses to create the connection. So now let's see how you can programmatically do that. Now, normally to do that programmatically, depending on the the implementation you use, you will have a specific class in your implementation, in your JP implementation, that can create the entity manager factory for that specific implementation. And I'm not going to go into details. Spring Boot, for example, it's very smart behind the scenes because it allows you to have not only Hibernate, which is naturally the convention, so you will most likely use, but you can replace it. So somehow behind the scenes it uses a factory to choose between the implementations. But in our case here, let's assume that we use Hibernate and that's it. So in that case, I can simply go with the Hibernate persistent provider class, which is the class we use to generate the entity manager factory. And then you have this create container entity manager factory. You will see that it needs two parameters to create the class. One is called the persistent unit info, which we will have to implement, and the second one is a map of properties. So first of all, I need a map of properties, which is the easiest thing I can create here. String props new hash map. Here it is. And this is the second parameter. And then the first parameter is that persistent unit info that we need to create. The persistent unit info is an interface that allows you to describe basically exactly what you would have described here with this XML description. So the driver, the URL, the user, the password, everything is here, has to be described using a persistent unit info file. So let me create a separate package for that. and inside this separate package I'm gonna say custom persistence unit info, and I will make this class implement the persistence unit info. Persistence unit info. Okay, finally. And then of course it's an interface, so all its methods or all its abstract methods need to be overridden, and there are quite a few of them that we will need to override. So if you take a look into the interface, you will see it's actually quite a large list of methods. Fortunately for us, not all of them are mandatory, so we don't necessarily need to go and implement each and every one of them. No, so I'm just going to override this and then take them one by one, and I'm just going to implement those, just going to not to implement. I did implement them, of course, all of them, because otherwise I couldn't compile, but I will just write something in those that I really need. And this, my dear friends, is an example of wrongly using the interface segregation principle. I have some examples from the real world of wrongly using principles out of the solid principles. So for those of you who don't know what the interface segregation principle is, you might have at least heard about solid. Solid stands, there are 5 principles out there. So solid is an abbreviation for single responsibility, open closed, Liskov substitution principle, interface segregation principle, and dependency inversion. So if you don't know what these are, I have a video out there about them. Please do learn them. They will help you write more maintainable code. This persistence unit info file, the way it's been created, is an example of how not to create an interface, how not to correctly respect this I here, meaning the interface segregation principle. Why? Because it forces me to override methods that I don't need. So the whole idea of the interface segregation principle is to allow me to only implement what I need, and this is not what I'm doing here. I will have to implement stuff that I don't need. Okay, now naturally you have to give a name. It doesn't even matter too much, but I'm just gonna keep the same name like here. Okay, so it can be any name. Actually, normally I wouldn't just return it from here. No, because this name might be something the application can decide. So you can have like the persistent unit name like that, and then just provide it from your application. So give it through the constructor, and normally all of them can work like that. So you can actually give all the values through the constructor. So you can do it like that. No, you say persistent, and then when you create the custom persistent unit info, because that's what you're gonna do here, is say new custom persistent unit info, and then you give the persistent unit name. See, PU name, and then you can have a string PU name here. And again, it can be whatever name you want, but I'm just gonna go with the one I've started with, which is my persistent unit. Is there any disadvantage of using JPA? Someone asks. I faced this question in an interview recently. The answer is yes, there are disadvantages in using JPA. Remember what I was answering to the earlier question where someone asked me, what do you think about Spring Data, JDBC, MyBatix, Juke, and some others? And I was saying those are alternatives for different cases. JPA implementations in general have the disadvantages of using, for example, the context of entities that I didn't start yet discussing in this event about, which means that they perform a sum of operations in memory, which if they are either not correctly performed due to lack of knowledge of the developer who implemented them, or simply if there are too many, there would be issues with using it. For example, I would never use a JPA implementation when I have to deal with large amount of records from the database. I would not use and I would not complicate my life with JPA if I don't really have complex relationships between multiple entities, because that's basically what all this ORM brings, is the ability to easily deal with relationships. But if you don't have that, then it doesn't make sense to complicate, to over-engineer your application with JPA for that. So yes, JPA implementations are not silver bullets. There are cases where you would not want to use them. And for example, there are cases where using plain JDBC might be much better than using any JPA implementation. And with Spring, for example, now that we have Spring Data JDBC, it's even better because, well, using plain vanilla JDBC would take a lot of lines of code to write simple things. But with Spring Data JDBC, which is an abstract layer over JDBC, allows you to do the same things with a very, very small amount of code, which is absolutely extraordinary. So whenever you choose the persistent layers technologies for your application, you have to very wisely choose depending on what your application does. Sometimes JPA implementations help us a lot. Sometimes they can become a burden over the time and make our apps less efficient and more costly. So I hope that answers your question. And I'm going to continue now. So what I did, I made sure my persistent unit implementation, so I created a persistent unit implementation. I made sure it has a name, and I used this name here to create the entity manager factory. See, this way, so I have the name and I have a set of properties here, and then I have used this Hibernate persistent provider because I'm using Hibernate. I have used the create container entity manager factory method, and then I provided the two parameters it needs, a set of properties which is an empty map for the moment. I will give you an example of properties just right after this example, and then the implementation for the persistent unit info. And then I'm going next thing we have to implement. So the persistence provider class name again depends on the implementation. So we know already which one this is that main class, which for Hibernate is the Hibernate persistence provider that you find in org Hibernate JPA package. But remember, this depends on the JPA implementation you use. So it's, if you want, as a comparison, it's exactly how the driver, the JDBC driver, works for the Java XSQL package interfaces. So there is no JDBC implementation in the JDK. Okay, you can't connect to a database just by using the JDK, even if you have there that Java SQL package, because that Java SQL package doesn't contain implementations. It only contains contracts, interfaces. So unless you have a driver, you cannot use that. So the same is here. You cannot simply use JPA without its implementation, because JPA in the end is just a specification. It needs the implementation, and the implementation comes with the provider, which you can imagine as being the main class, the class you start by loading the implementation, which is this one for Hibernate, and that's why it appears in the persistence XML file, and that's why we also have to provide it here. And then the transaction type, which you need to provide, it's either JTA or resource local. Yeah, you can use resource local, for example, like we did in the previous, and then get JTA or non-JTA data source depending on the transaction type that you used. Remember, all of these are exactly what we began with at the beginning of our description. So here I can say how it's called, Hikari something data source, the name class. So see, Hikari data source, I'm gonna show you now. It implements, this is the data source interface from the Java SQL, Java X SQL, sorry. Okay. And Hikari does implement the data source interface, which makes it a data source for the JDBC. So that means by means of polymorphism in Java, I can return the data source here. So data source set, and then I need a minimum of the JDBC URL, username, and the password. And again, this should come from somewhere where it's secured. So I will put them here in code. I hope you allow me put them in code here. But remember that they should never stay in code. Normally, same as I did with this PU name, they would probably be initialized outside somewhere, taken from a vault, and then provided to create this object. No, but now I'm gonna just copy. Oops, I'm gonna just copy all these values here. And I'm gonna save time because I'm pretty sure you know how to put them outside and get them in. And then mapping file names, no. Jar file URLs, no. Persistent unit rules, manage class names. This is what I need. I'm gonna put it a little bit up here. Okay. Let's move all these that we haven't used down below. Okay, so non-JTA data source, manage class names. Here is where I need to provide a list of all the classes that I use as entities. And now you might wonder, well, we do not do that with Spring, don't we? But then we do not do that with Spring because Spring actually uses reflection to get those and put them here. But since we will not afford the time to do this now, I'm just gonna list them manually in a list like this, and this is how it should be done. Okay, so this is just because otherwise there is no way the Hibernate, the JPA implementation, knows where to find the entities themselves. So how does Hibernate know where to find the book as an entity to scan it for the annotations? It can't, no. Okay, we don't exclude, we don't cache anything, we don't validate, no specific class loader, and that's basically it. No, so that's the minimum you need. Of course, you can configure it up to the end, but remember what I was saying. So normally this persistent unit info file should have been split in such a way in which I can decide whether I want or not to override, and I can choose to override only the things that I only need to override, which are these 4 methods. This is another good example of a wrong interface segregation from a real world stuff that we are using very often. So normally we can now check this, and I can start this again and see if I did all good, or if I missed something. Okay, we let it compile, and it should be right there soon. I see it already starts initializing everything. As you can see, the result is the same. So we ended up with the book. So that demonstrates that my implementation here works in exactly the same way as it did work with using the Java, the persistence XML file. So these are basically the two ways in which you can implement the connection to your database. Now we will continue with the programmatic approach. Anyway, we will not have to touch it anymore. I just want to make sure you understand that we have these two options and you know how to use them properly. So we have the first and the second. The only thing I would like, however, to add here is a set of properties. So maybe you wondered, okay, I had to put this prop map here, but it was an empty map because, of course, I'm not forced to use any properties. So it's not a must for me to use any properties. I can provide them if I want, or I can simply provide an empty map if I have no properties. But if I want to give specific properties, I can do that through this map. And some of the properties you can use, maybe one of the most used of the properties would be the one I was telling you a bit earlier for showing the SQL. So in this case, you would write Hibernate show SQL true. So let's see what happens if I'm adding this line here in the properties that I have forwarded at the creation of the Entity Manager factory. And while it's running, I'm gonna also answer the question, could you also talk later about Hibernate's first and second level cache? Yes, of course, I think we can do that as well. So it's running. And you can see the difference is now that I have been provided also with exactly the query the app runs. So this is a very important property that you want to use, because otherwise you don't know exactly how these have been retrieved, which was the query that has been used. Yes, I know this is a simple find. Maybe you say, hey, it's simple, but I'm talking here about real world applications in which things can be a lot more complicated than just a find, and then you really need to figure out if the native queries created behind the scenes work the way you expect them to work. So are they exactly what you wanted them to be? Another thing, but I'm going to show that one later, is we can put it here just to have it, but you will often see with examples and tutorials is the Hibernate HBM2DDL auto, which can have the values none, create, or update. I'm going to put it on none now, and I'm going to explain that this can be used to allow Hibernate to generate the tables for you. So what we usually do is that we already have the tables. Like I started, now I had a books table, and I started creating my entity class from the table, adding the right annotations here depending on how the table look like. But for examples and tutorials, you can save some time, and if you only want to focus on the entities themselves, then you can simply just use this Hibernate HBM to DDL property to create or update the tables, or the already existing tables, based on the way you have created or updated your entities here. Remember, however, that this should never be used in a production ready application. So in a production ready application, we always want to use some software that versions correctly all the scripts that have been run to the database, and JPA is not made for that. JPA cannot do that. Normally you would either use something like Flyway or Liquibase for that, but never use Hibernate to automatically create stuff for you in production. So this property is something you only want to have in tutorials and theoretical demonstrations. I'm gonna prove how it works later, but that's what I wanted to say from the beginning. And this is how we conclude here a first part of today's discussion, where we figure out a lot of essential things about how we create our connection to the database. You understood the two ways, persistence XML and the programmatic approach. You understood that we have to create an entity manager factory, and then we have this entity manager that we actually use to execute operations, and you saw what entities are and how we create them. And now we're gonna step into the next part of this discussion, where I'm gonna assume now that all of these are known for you. You understood them, hopefully. I answered all your questions you had in the live chat. And now we can focus a bit on the entity manager and what the context is. And the context is also basically what we refer to as the first level cache, if you want. So I'm gonna talk about this way of this management of the entities, the way the JPA implementation Hibernate manages the entities in this so-called context, and the way we should remember how this works. Because when we work with JPA implementation, we always have to have this philosophy in mind of we are not running queries to the database. So remember, it's very easy to be trapped with the idea that an operation here runs a query on the database, but you will see that with a JPA implementation this is not the case, and you should stop simply having that philosophy of operation per query that is for JDBC implementations and not for ORM implementations. And I think it would be actually best if we create another application so that we can keep this, or should we work on this one? Oh, we can still work on this one because we only have one entity, and then we can describe using this one and step at another example when we go to relationships. So what I was saying is that here, with the entity manager, this is the manager of a context, say manager of a context. So this context, you can imagine it as a place. If you want, if it's easier for you, you can imagine it as a collection of entities that are managed from the beginning and until the end of the transaction. So this is basically like you have you imagine the entity manager as a person having a set of objects that it manages. It can change that set of objects. They can add new objects, that they can remove objects. Now, and when you create an entity manager like you do this way, there is nothing in the set of objects. And there are different operations you can use. This person here, the entity manager, can execute different operations to work with this context. Which are those operations? One of them you have already found is the find. And this find is get from the database and put into the context. Then another one the manager can do is the persist. You can write something like that. So what does this actually mean? Sorry, B2. Does this mean that when we call the persist, an insert goes to the DB? No, it doesn't mean that. It means that when we call the persist, an instance goes into the context. This is the place where the insert might go to a DB. So it's a big difference when using a JPA implementation, a big difference in how we think when using versus using JDBC. Because in JDBC, when you call something like persist, this is the place where an insert happens, and this is the place where the transaction commits. But when you use JPA, this is the place where simply an in-memory collection changes. And this is the place where before committing the transaction, also the inserts happen. There are some configurations where you can change that. I'm not going to talk about them. I'm talking about those 99.999% of the cases, because it's very unlikely you will ever change that through configurations. Trust me, it's unlikely. It's not even recommended. So that's why I want to continue talking about this approach where we think about how this context is used. And for us, Hibernate has an entity manager, and the entity manager manages a context. And the context, this is where I say when the transaction is committed, context is mirrored to the database. So the context managed here is going to be mirrored to a database. And it's important because guess what can happen if I say persist B2 and then remove B2. Okay, let's run a bit this example. Oh, this is actually strange, no? Because normally I would have expected to not see anything here, and I'm wondering how I do see it. So normally that's exactly one of the points. That's a very good point. Actually, I'm gonna run it. Nothing normally happened here because we added and removed, but one of the things that you need to know about ORM frameworks is that even with a lot of experience, and I did started by saying this, you might not be sure that this will actually happen or not. So for example, I would have expected that being in a context here and persisting and removing the same entity would not end up with an insert and a delete at all. But in this case, for some reason I cannot explain, Hibernate decided to do that. Why? Maybe it was the best choice. It is in internal. If you go behind the scenes, you might or not be able to explain this if you go and look throughout the code. But normally, for example, this shouldn't have ended up in creating a persist at all. But there are explanations. So sometimes it does that because it makes sense. So that's why you always have to use this or do some profiling when you finished what you implemented to make sure that what you did is the right thing to do. But one thing that I'm sure about is that they shouldn't happen here. So I'm sure, and the amount of confidence is still not 100% because I'm using Hibernate now, and as I told you, it's something that you are never sure when it's about how native queries go behind the scenes, and that's where mistakes come, and that's why using Hibernate in situations where you shouldn't use it can become a burden, because even with a lot of experience you might end up with things that surprise you. So keep that in mind. This is what anyone with experience with ORMs would tell you. So I'm going to rerun it, and you can see actually that for some reason the insert happened before committing the transaction, but the remove itself didn't happen. So and I know exactly why. I know exactly why this happens, and I will explain it to you. In this specific case, the persist have been forced here by an automatic flush, it's called. And the reason it did that is because I'm using an identity auto generation strategy, and I'm going to explain this with a diagram because it's not easy, but observe one important thing on how it works now. So this didn't generate a remove. This one, for a reason I will explain immediately, generated an insert. So you can see the insert happened. You can see we passed over the remove. We are just before executing the commit, but the remove didn't happen even if you executed it. But if I'm gonna go one line down, the delete appears as well, and then of course everything closes. Let's explain this behavior. It's very important always to try to figure out what happens. So I'm gonna need a draw IO, so let me open something where I can draw something, because without drawing I will not be able to explain it. Okay, 1 second. I'm gonna just open it and put it on the big screen. Okay. So what happens here? This is the database. Okay. And this is our application. Actually, I want you to think about the context here. So this is not only our application, but our JPA context, which is that in memory collection behind the scenes. So what did we do? We created a book and we called it B2. When we persisted the book, it went into the context because that's what the persist operation does. But there is a trick here. We have configured our database to use auto increment. And because it uses auto increment, when I persisted the book, it doesn't have an ID yet. No, when I created the book itself, I simply just created the instance. I didn't set an ID and I didn't set a name, a title. The title is not relevant, but the ID is. The reason I didn't set an ID is because I know it's identity generated. So I know it's the responsibility of the DB to generate me the ID. But the database cannot generate you an ID unless you create the insert. And Hibernate is smart and it knows that. And because it knows that, even if this is a persist which might be followed by an operation that removes this, it's forced to go to the database and ask the DBMS, hey, please persist this in order to get me an ID. So the only reason why in this specific case the persist happens before is because there was no way for Hibernate to get the ID. So here it is. It got the ID. But then when it came to the remove, what we did with the remove is we removed B2 from the context. However, the remove itself didn't yet generate any delete. Why? Because I could have just recreated it from the code logic for I don't know any reason, and then the delete was not needed. So this way, what Hibernate tries to do, what our JPA implementation tries to do here, is minimize the number of operations. Normally, none of them would have been needed, but the only reason it cannot skip over the first is because of the auto increment and the necessity of the ID. We can try to force this happen. We can try to force the insert not happen at all by changing the strategy, the generation strategy from identity to none. Well, basically none being like this, but then we also need to change it in the database. So let me do that. So I'm going to remove completely the table because I don't think I can do it other way. Okay, let me see. So it did remove it. And then I say create table. I will name it books, so the same. But the ID this time will not be auto increment. I will not check the auto increment. It has a title. I'm creating it. And of course it's empty now, but we don't care. No, it's an empty table. Fine. But it's irrelevant because we are talking about creation here. So let us do the same, execute the same application without any change. See if anything happens now. The only change has been the generated value. No, I took out the generated value. That's what I did. So it's not an auto increment anymore. Okay, and that's it. No. Manually assign. Okay, fine enough. Sorry, I used integer, which is null, so it forces me now to use also set an ID, something like that, because you cannot have a null ID. That's fine. I do agree with that. I'm gonna rerun it, but setting the ID myself. Or I could have simply just used int instead of integer, and then the ID would have been 0, and I didn't need to write this line unless I wanted to put another ID, which is not the case for this example. Okay, go, go, go. No, I still see the insert. This is strange because I thought that this will solve the insert. But again, what's behind the scenes of Hibernate is behind the scenes of Hibernate, so you cannot always rely on this kind of stuff. So it can happen that depending on what you do, you will not see that persist either. The point is, it always works with the context, and all or some of the operations will be done here at the commit and not here at the persist. So if you do anything, like I'm now in debug again to see it. Okay, go here, set the ID. I'm gonna do the console. And you see now, actually the persist didn't generate the insert anymore, which is a change in what we observe. I expected that. And then I do have the remove, which doesn't do anything. But for some reason, it still decides at the commit to do both of them. So it did change exactly the way I thought it will change. Remember the first, if you go back, rewind, if you don't remember what we have seen previously. Previously, the persist was already generating the insert because it needed, and I was explaining it here, to get the ID. So that persist was basically done at the persist level, by a forced flush. That's a forced flush, meaning it forces at the operation to go to a database before the end of the transaction, just because it needed to do that. Just because there was no other way to get that ID. That's the point. And now it doesn't happen. Now there is no forced flush. Just because having no more generated value set, just because there is no longer an auto increment there, it doesn't need to go to the database. It simply just, in this case, add the B2 and then remove the B2. And then normally, for such a situation, I would have expected that even at the end of the transaction, those will not happen. Now, I'm curious if it's only the generation that happens or it really sends them, but it doesn't really make sense to send them. But remember, you cannot know what Hibernate does behind the scenes. It can be even depending on the version of Hibernate that something's happen in a way or another. Like, for example, in this case, because I added and removed the instance with the same ID, for me it didn't make sense. But maybe it's just because I forgot to override the equals and hash code. No, I forgot. I didn't want in this case. But there could be a lot of explanations for this. No, in this case, being an example, I didn't do that. So now I'm going to override them just based on the ID, no? So go here and do that. Now I'm curious if that is it. Why? Because if they are in the context, what do you think Hibernate uses to map if B2 and B2 are the same. Well, this is actually the same instance completely, which is kind of strange, but it can be. It can be. No? And that's why you need to always print or profile your queries to see that what you do is or not expected. No, still happens. So in this case, it was not the case. But in a real world situation, imagine more complicated queries. You do have to review them. It doesn't matter it works. You do have to review what happens behind the scenes. Because even with the simplest things, depending on how your database looks like, depending on how your entities look like, things can work differently. And that's what makes Hibernate difficult. And that's why many developers make mistakes. Because they simply go with, hey, it's working, I don't care. But in some cases, that I don't care can become some queries that completely affect the way your application works. And see, even with the simplest examples, there are changes in behavior with small things that you actually change. Okay, I think I made my point with that. So I'm gonna say we can continue with the entity manager operations. Now we say entity manager, we said find, we discussed about persist, we discussed about remove, and then we have a few more, like you can merge something into the context, which means that thing is already outside of the context and you just want to put it in the context. So for example, you have an entity, your B2 is outside of the context, and then you want to put it in the context. So it's not in the database, but it's outside of the context. You put it in the context. That's a merge. So you merge it to the context. And then detach, which is the opposite. So you don't want to remove it. You just want to detach it from the context. Okay, just want to take it out of the context without removing it. I'm actually curious what would happen if we change our example, like we had book B2 new book B2 set ID 1, and then you say detach B2, which is no longer in the context. So normally, sorry, em persist first, you put it in the context and generate a persist, and then you detach it from the context. This is also interesting. So earlier we had a remove here, but what if you use a detach? And the question is, will that insert be or not generated? There will not be a delete anymore because the detach doesn't create a delete. The remove generates deletion. So this generates a deletion. This detach only takes the instance out of the context. The merge adds to the context a detached instance, meaning an instance outside of the context. Okay. Persist adds to the context, and then adds or marks the entity as to be inserted. Yeah, and we can see it's an exception because, well, it cannot actually, it has a marked for persistence, marked to be inserted entity, but which has been taken out of the context. So only what's inside the context, no, it can be operated with. So if you mark this to be inserted, but then you take it out of the context, that is a problem, no? So you cannot work with a detach operation. What else do we have here? So we have it. Anything that I've missed? Okay, fine enough. So these are basically the operations. So now what I want you to imagine is that you work with the context itself. I still feel that I'm missing something here, but anyway, you can find something from the DB, persisting it. It means put it in the context and mark it to be inserted whenever possible. And we have seen that whenever possible can be different between different configurations of your database. So you have seen together with me here, we use the debugger to prove that when we had a thing like auto generate the ID, it had to persist it at the moment of the persist, because otherwise couldn't get the ID. But then when that was not the case, the insert has been generated straight here. The remove that generated the delete, the merge, the detach, and so on. Okay, some questions. So if we use detach with persist, insert query will be fired and then exception. I think it doesn't fire anything. Oh, it is actually, no. Insert, it is fired and then you have an exception. Yeah, indeed, it's true. Why we got exception in case of detach and not within the remove? Because remove actually marks it for a deletion. It's an operation that generates a delete on the database. So remove, it's actually marks it to be removed and then detaches it from the context, while detach is not a remove at all. So detach only takes the instance out of the context, while remove generates a deletion, and of course after the deletion the instance is taken out of the context. But remove is specifically for deleting a query, while detach is not for deleting an instance. Sorry, not a query, an instance. Okay, now what about the update? Now the next thing that usually people ask me, let me put this a little bit up there to not be disturbing. So what I'm usually asked about is, what about the update? So let me see, do I have any book now here? No book here. I will have to add one. Let me actually add one first. So I'm gonna do like that. Say book b1 new book, b1 set id 1, b1 set title troubleshooting Java. And then of course entity manager persist, that we have already discussed about it, generates an insert, which again in this case will happen here, the commit. So here it generates an insert, but initially, say after initially putting the instance in the context. No, because the most important thing we always have to remember, these operations are only the entity manager working with a context, not with the database directly. And I'm gonna run it. So could you give us an example of observer pattern with Spring Boot? Yes, I could, but not in this marathon, which is not about Spring Boot at all. Okay, so let's keep that for another example, for another video. Okay, so I did insert in the database. I'm gonna comment this out now. And I'm trying to take a look. So it would be 1. But just to make sure, let's take a look here. Okay, ID 1, troubleshooting Java. And what if I want to change the title? So the question is, what if I want to change something on the entity itself? Because there is no operation for changing anything. There is no update, there is no entity manager update or edit, or there is nothing like that. And that is something that I see it creates confusion for many beginners. How is that I cannot update? How is that I don't have an operation that generates an update? I do have for insert, and I do have for delete, and I do have for select. But where is the update? And the point is that there is basically no operation because it's enough to change the entity itself. So if I change this troubleshooting Java, no, that's how it is in my database now. Here it's troubleshooting Java. And I'm gonna change it with Spring Start here, which is another one of my books. See, I don't do anything. I'm just getting it with find so that it is in the context. That's very important. And then I just change the title, and the update will automatically happen here at this line, at the commit line. So let's run it and see. Okay, now pointer for some reason, but it's B1, not 3, it's 1. That's why. Yeah. So let's run it again. So local and refresh operation can we use? Yes, indeed. Refresh actually is one of the important ones. It's some kind of undo. If you want to at some point make sure that you take it back the state as is in the database, you can do a refresh for a specific instance. You have to be careful with that. It generates a query, a select query, and sometimes if you rely on that too much, you might create a bad design, with not really fortunate performance if you rely too much on refresh. But at some point it can be a way in which you can say, hey, I might have changed things on an entity, but then I want it to go back to the state as it was in the database. So I did generate an update. See, this is the query for finding. And then you can see that this update came from nowhere. Actually, it came from the fact that the instance, the way it was initially in the context, changed throughout the logic before reaching the commit state. So this change of the state of the instance is what automatically generates an update. And of course, that update will also reflect at the database level. So now the title of the book changed from Troubleshooting Java to Spring Start here. But you have to be very careful. These operations can only apply to things that are by any means in the context. So find puts them in the context. But if I would have tried to do something like book B1 new book, b1 set id 1, b1 set title and then another title, back to troubleshooting Java. This will not reflect in the database. This will actually do nothing. Okay? Why? Because this, instead of being an instance in the context, it's simply an instance that has been manually created by me here. So if I'm gonna run it, I will not be able to see it in the database. Let's run it and see that this is indeed the case. Okay, so you can already see there has been no update generated in the console, but you can check and see that the title still state spring start here and it hasn't been changed. Because JPA only works with its context. So if I simply create a book instance and I set the title and expect that it somehow magically knows that it has to find this in the database, it won't happen. But if I would have done something like merge b1, so I'm merging this to the context and then I'm changing the title, then I can expect an update to happen. So let's see it. Yeah, and you can see automatically, because of the merge, it had to find it in the database that was not already there, so it had to find it and put it in the context, and then the set title generated an update. So this is just to prove that it, regardless of the way this arrives in the context, by simply changing something on the entity, anything, it will generate an update in the database. And then we can see the title is null for some reason. I don't know why. In this case, it started with a lot of ghosts today, so but we can investigate again why it happened. So I took the b1 was null, and then I changed the title. So somehow I would have expected the new title to be troubleshooting Java, but it ended up as null. While I do agree here it was null initially, I did change it here, so strange thing. But it did generate the update as I expected, so fine enough. For me, at least. Well, Hibernate is difficult. There is never you have too much experience and you know everything, because it simply changes even from one version to another, even from one configuration to another. And previously you were asking me about downsides. Are there any downsides for not using JPA? Yes, there are a lot of downsides. As you can see, even with the simplest things, somehow you might end up with things that you don't expect. No. So get reference. Get reference is actually very similar to find. That the difference between get reference and find is that get reference only gets you a proxy to a specific instance. So that means that values others than the value of the primary key are not loaded at the beginning, and they are going to be loaded only if you request them. So I'm not sure how to prove that. I can try, but I think it would be something like, now say you get this, and then you say b1 get title print it. So, and run it. And let's see what happens. Now we are running it and we will immediately see what happens. Okay. Not really. I would have expected here to see only the ID and not the title. So normally what happens is that with get reference, you will not necessarily get all the values, but only have an instance for that. I think it actually it does. Let's put it here, the breakpoint. And I think what we should be able to see in this case, again, difficult to prove this, but what we should be able to see is that this line doesn't trigger a select query at all. And it is this line that triggers the query. So let's see if that's indeed the case. And then we will try to replace it with a find. So I'm gonna then run with the debugger. And here is the console. And let's see that. So my point is see when this query is generated. Okay, if I got the console, no, it has been already generated. It's very strange. So I don't know in this case why this works like that, but it might actually simply be because of the IDE, because you see here the IDE somehow triggered the query to show this on the right side. So I really don't know how to prove that, but normally the get reference only gets you a proxy, and that proxy doesn't trigger the query unless you use it. While in my case here, I think that you see it in the console because the ID triggered it to show this on the right here, even if it wasn't already used. So pretty much difficult to demonstrate that, but that should be the case. I will think about a way to demonstrate that, but I don't know. I don't have in mind now something. So the point is, theoretically, this B1 would not generate the query unless you really use it, while when you use find, it simply generates the query, and then even if you don't use that instance anymore, it's still there. I will figure out if I find a way to prove that somehow. Okay, so that's basically with the operations. Okay, I can actually delete all this now, and we can focus a little bit more now on the entities. So we saw, okay, there are some operations. I think I also had to add the refresh here, which is re-establish the data in the instance the way it is in the DB. So it's kind of an undo for a given instance. I think there is even a refresh all, no, if you want to do that, but even worse, no longer refresh all. I think it has been removed, fortunately. So these are all the operations I think that that we need to know about the entity manager and work with them. Now, normally, unless you use, say, even if you use the entity manager directly, you do use a lot, maybe persist and maybe remove. And these are the two operations that will be the most used out of all you see. You can operate any way you like with the context, but most of the operations, out of all the operations, the most used are the persist and the remove. The find itself is not very often used, also because finding only by the primary key is not necessarily very frequent. Usually when you query something, you query in different, more complex ways so that you can find stuff, and for that we are either using JPQL or criteria query. If we want to programmatically define our queries, so most cases would be JPQL, and in some cases you might use criteria query. So we are going through that as well, but I would suggest first, before going into that direction, talk a little bit more about the entities and the way you can define them. Okay, let me see some of your messages. So on the get reference, I tried again. So normally get reference, what you can theoretically remember is that it generates the query only when you really use that instance, while find always finds that query. So that would be the difference. I don't know how to prove that, however. So in what cases we can use get reference? Normally you can use get reference if you know you potentially you will use an instance, but you are not 100% sure. So then if you use get reference, the query will be generated only if you really use that reference. Say you have something like I need to get a book B is, and then is the book that you found, and then if something, then you use the book. And then in this case, because you don't know if this condition will be true, it's better you use get reference here, so that the query for getting the book is used only if it gets through the if and not when it goes through the else route. While if you know for sure you will use the book, then you can simply direct use find. So that's basically it. Can you explain how to use Hibernate with an enum? Yeah, of course we can. So we can have enum attributes for any entity, and we will be able to use through the enumerated annotation. There are two ways in which you can use it, through ordinals and string, and we can detail that to answer your question right now. Why not? I guess you have to set site title to use while using merge. That's why getting null as a title. I'm not sure. Didn't I set the title? I deleted the code, but I remember I set the title. But maybe you're right. Maybe I'm just I was just in a hurry trying to explain and I forgot that. Does the interviewer got this deep? I'm not sure what that question. What do you mean by that question? Please make it a little bit more descriptive. Who is the interviewer? When are we talking about? What interviewer are you referring to? I don't know. What do you think of the I don't see exactly what that word is. Blaze persistence. I don't know what is blaze persistence. What do you refer to again? Not something that is that I'm knowledgeable of. Okay, fine enough. I'm going to show that enum stuff. No, so let's say that in our case here, the book, besides a title, and I'm gonna actually delete it completely. I said drop table, and I'm gonna create a new one from the beginning. And let's say that we have a technical and non-technical. So ID, I can make it auto increment, title, and then it will be type, and this type can have two values, so it would be either technical or non-technical. Now I do have two different ways in which I can refer to the enum here, which would be either a string, case in which I can keep the varchar, or I can use the ordinal, case in which I would have to change this to an int. So let's try with my favorite is varchar. I will explain also the difference and when to use them, but let's see it first in action. So I'm gonna apply my changes here, and then I'm gonna go to my book entity and change it to reflect all this. So this is it. And in the book, if I did that, I'm gonna set again the generated value strategy identity. And then I have a private, and I need an enum, no? So let me do it like this. I'm always keep my things in order. So I'm gonna create a package, and I'm gonna name it book type, and the book type is an enum, and the enum has two values, technical and non-technical. Oh my god. Okay. So I'm gonna say private book type, and I call it type. If I want, see, I call it type because this is the way in which I define this at the database level. So let me make sure that this actually correctly created my table. See? And you have the type here. But if I, for example, in the code want to name it differently, say I want to call it book type, then I must use the column annotation to map it to exactly the column I want to. So remember, this works without the column annotation as long as the name of the attribute is the same with the name of the column. But if the name of the column and the name of the attribute differ, then you must use the @column annotation. Now, you also want to use the enumerated annotation, and what you want to make sure is you specify how do you store the enumeration, and you have the two ways I was saying earlier. So ordinal, meaning the order the value has in the annotation, in the enumeration, sorry, and string, meaning the exact name of the value in the enumeration. So I did say I will choose with string first. So let's see what that means. I'm going to main here, and I'm going to try to create a book and persist it. I don't need the ID because it's now oh, and I need, sorry, I forgot to add the getter and the setter for that. And normally I should also update it to string, you know, if I want to see it in. Okay, so B1 set title troubleshooting Java, and then B1 set type, and yeah, clearly it's a technical one, this. Okay, and then persist B1, and let's run it, see what happens. Okay, did insert everything, and I'm gonna try C and look. So it's technical. Fine, that's how it works. So that's how you do with enumerations. The second option, and I'm gonna delete the table now again to show it. And recreate it. So again, books, ID, auto increment, title, and then type again, but this time type will be an int. It's still an enumeration, but it's an int. And now I'm gonna change in the book, and I'm gonna say that this is reflected not by the string, but by the ordinal. And I'm gonna run the same example the way it is. I'm just running it the way it is. Okay, and now check again in the database. And what you will see is that type is 0. Why 0? Because 0 is the ordinal for technical and 1 is for non-technical, no? So if I'm, say, adding a second book, which is, I don't know what exactly, to add here, and which is the non-technical one, then this one will be the ordinal, will have the ordinal 1. So, which is the best way to use enums? String or ordinal? Ordinal has the advantage of being a number, which has the advantage of being smaller and at the same time easier to index. So if you expect to index on the type at the database level, having an ordinal is definitely from the performance point of view better. Let's say the amount of space is not that a big deal, because usually the annotations are also have small names, okay? But that would be the two advantages of having ordinal. However, the text, the string, which is my favorite, the one we started with, has the advantage of if you change in the code the order, it will not impact the data. And for me, this is critical. Because look what happened here. I just changed in my Java code the order for technical and non-technical. And you can guess what happened now. If I'm gonna just try to find my book, which is troubleshooting Java, it will now appear as non-technical. And that's definitely messed up completely with all my data. So you don't want to do that. You don't want to get in the situation where you end up with that. See, and I ended up with troubleshooting Java being non-technical, which is not the way I've added it. And it was pretty easy. I just changed the names. I can just go back now, no, change it back, and prove that the same, see, the same application will now show the other one. So it's not really robust from the point of view of coding. So even with the advantages that the ordinal has, unless it's really critical for me to index on that thing, and the indexing on that really helps me a lot, I would never choose on using the ordinal, because that's what can happen very easily. They can very easily screw up with all the data that you have only by making a small change in the code. So it's very, from the point of view of the code itself, it's not really expected. Okay, fine. So now, of course, the next thing you might want to think about is relationships. So let's say you have a book and an author. And now I'm gonna show you also how to generate the tables, because up to now I only did it the production way, generating the tables and using them from your application that uses Hibernate. But you know, I told you, with tutorials and examples you can save a lot of time if you choose to allow Hibernate to generate your tables, because if you are not specifically learning how to write DDL queries, then it doesn't really make a lot of sense to spend a lot of time every time creating the tables like that, or writing the queries for that, or whatever. And then you can focus on Hibernate. But again, remember, that's only for tutorials. So never do that in real world applications, because you will end up with, you can end up with situations where you don't know what changes have been done. You might end up with situations where changes that have been done are not the changes you'd like to have, and you never have this way a clear report on what exactly has been run on your database. Hibernate is not made to generate your schema, okay? Hibernate is made to work with the data inside. So that's why in production we use scripts, we use dependencies such as Flyware or Liquibase, but we do not use Hibernate to generate. But for tutorials, going back now, it's tutorials what we are doing here. If I want now to allow Hibernate generating them for me, I'm going to show you how that happens. So I'm going to create a new entity, author, and I'm going to say private int ID. I'm marking it as an ID. Generated value, again, strategy identity. Private string name of the author. And let's say, for the sake of this example, that we want to say that an author might have published multiple books. If I want to represent somehow the relationship between author and book, I have to use the relationship annotations. Let's start actually from the simplest. I would say in this case that an author may only publish one book. So how can I represent a relationship between book and author if I assume that an author may only publish one book and the book may only be published by one author? If I do assume this cardinality, then this is called a one-to-one relationship. And the simplest way to do it is to go on either of the sides and say private book in this case, which is the book the author has published. I know it's not realistic for the moment, but I don't want to change my entities just to make it realistic. Just assume in this case an author can only publish a book and the book might only be written by an author. This is one-to-one because one author publish one book, a book can be published by one author, one-to-one, okay? And in that case, if the relationship between your entities whichever those are is the one-to-one, then you simply have to add the one-to-one annotation over it, and that's it. So that automatically creates the relationship between the two entities. I'm gonna create a getter and a setter, and I'm gonna tell you something very important. Whenever you have relationships, be very careful with the toString methods, because the toString methods, if you generate them automatically and they include a relationship, the relationship might be bidirectional, which means that the book will show the author, and the author will show the book, and the book will show the author, and the author will show the book, and you will end up in a loop, which is in the end causing a Stack Overflow. So this is a very common and often encountered problem, especially when beginners start with working with Hibernate. I can even prove it to you, but let's start with this beginning. If, however, I have only referred the book from the author, but I didn't refer the author from the book, this is called a one-directional relationship. A one-directional relationship is because only one of the sides know about the other doesn't know about the previous. So this is one of the ways to do it. And let's see what happens. So I'm gonna go to main, and I'm going to enable this, say create. Remember, we were discussing at the beginning of this event that you can use this Hibernate HBM to DDL auto property to allow Hibernate generate the DDL for you. And now if I want to create a book B1, new book B1, set title troubleshooting Java, set book type technical, oops, and then author, name, and then book, no, B1. Observe that I have to create correctly the relationship between them. Both of them have to be added, and we have two options for that, but the easiest is just persist each and every one of them independently. So using the entity manager, I'm going to persist both the author and the book. See, I have one persist here and one persist here. And now I'm gonna run this example and see what happens. So normally it should also create now the tables. That's why you see drop table. Okay, we do have some problems. We know which is the problem. Remember that I have created a new author, but being that I'm using now this class, whenever I'm defining new entities, I must be sure that Hibernate knows about them. And that was right here, which means I should have added the author to the list as well. So let me do that. Oops. So I'm gonna just run it again. Okay, here it goes, it's running. Okay, still some problems, have no idea. Oh, damn. Okay, author, I think it's also a reserved type name, no? So that's a very interesting one. I'm happy that I ended up with this, because if I didn't, I was not able to explain it. So one of the things you have to be careful about is that some of the words you might want to use are reserved type names. And to be honest, I don't know all of them, and they might depend on technology, but it seems that author in this case is one of them for MySQL. So then what I need to do is to make sure that I name the table in a way in which it is not using a reserved type name, because if I didn't use the table annotation at all, then it tried to use author exactly as is here. So author being a reserved type name in MySQL, it of course failed with these errors that you can see here. So what I'm gonna do is I'm gonna just name it authors, just for the sake of my example, and now it should work. So be very careful with the namings you choose to not overlap with keywords in the technology that you are using. So third try, hopefully lucky. And we will also be able to observe the names, the DDLs, the queries. Okay, here it is. So we have some drops. I'm not sure what this is actually. Okay, try to drop a table that doesn't exist. Makes sense, because I've changed the name, so it tried to drop it, but it didn't exist. Let me actually make sure that it generated. Oh, not create, sorry, refresh was the thing I wanted to do. Okay, authors, books, makes sense. I'm gonna go here and see inside. It's me. You can see the foreign key there. And in the books, again, you can see this type 0 because I left it as ordinal. So this is only because I changed that and it didn't exist. But then you can see, so drop table, authors, drop table, if exists books, and then it created both of my tables. It even created a foreign key constraint for my foreign key and an unique key constraint for the primary key, and then it did insert both of the records that I requested. So that's why I ended up. And being a one-to-one relationship, so normally I do hope, friends, that you already have some basic SQL knowledge to establish the relationship. When we have one-to-one relationships, we use foreign keys. So what is a foreign key? Is the ID of the other table used on the record of the one with which we create the relationship. So in this way, the author with ID primary key 1, name allowed, and it is associated to the book with ID 1, which book with ID 1 is troubleshooting Java with type 0. Of course, the relationship itself, so the foreign key, has been added to the authors table because I have defined the relationship itself in the authors. So that way, this becomes the owner of the relationship, and the owner of the relationship is where the foreign key is. Another thing that we want to observe is the name of the foreign key column has been automatically given with the default because I didn't override it with anything. So the default being name of the entity underline name of the primary key, so book underline ID in my case. I can override, so let's see what happens if I want to provide it with another name. So I'm gonna drop these two tables. Okay, and now normally they are dropped. I'm gonna go back to this example and I'm gonna use a join column annotation to provide a given name to my foreign key. So this is the foreign key, and then if I want to provide it with a name, I'm using this name attribute, name book. Initially was book ID. Now it will only be book, or whatever I'm writing here. It can be any string as long as it doesn't interfere with any reserved type names in the technology I'm using. And book, hopefully not. We will see immediately, maybe. But if it's not, then it will be usable for my column name. Okay, so you can see it did the same thing, and somewhere here we should be able to see that the name was indeed book. So if I'm going here, I should be able to prove it as well. Refresh, authors, and the name is no longer the default one, is the one that I have given. Another thing that we want to remember is that going back here to the way we persisted the data. So I did persist independently the book and the author, and that's something, yeah, it's normal. Again, it's something I needed to do. But if I have a situation where I know that a relationship will always be persisted whenever I persist its parent, then I can use a cascading, because the cascading being given on the relationship annotation. So see, I have the relationship annotation here. One of the attributes that you can see here is cascade. And then what you can do is decide which operation you want to cascade. For example, in my case, I can decide to cascade the persist. And then in this case, I'm going to prove it. Again, every time, in my case, by deleting this to make sure that they are empty. And it's like starting the example from the very beginning, so that you see that what I'm doing here really has the expected result. If I'm using the cascade here, so it's only enough to persist the author, and then automatically the book, which is its relationship that has been marked with the cascade type, will as well be applied with that operation. So in my case, I don't need to persist the book anymore, because I know it will automatically be persisted here, because the persist operation is cascaded. So I'm going to run this, and I'm going to then observe that we see the same result, and the book is cascaded because the book is persisted because of the cascade I have set at the author level. Okay, you can see the two inserts have been done indeed, and we can check that we ended up with the same result, even though we didn't manually configure the book to be persistent. The book has been persisted. Best practices about this, and now I raise the hand for something very important. I can decide that I want to have multiple operations. So for example, if I want to have cascade for the refresh, for the persist and the remove, I can put both of them in an array with the normal array syntax on the annotation, and then both of these will be cascaded, which means if an author is persisted, the book will also be persisted. If the author is removed, the book will also be removed. But be very attentive. A best practice is never to use all. First of all, it's very rarely to believe that all the operations need to be cascaded. But even if really you are in that situation where all the operations need to be cascaded, then it's preferably to enumerate them just to be visible that it was your known decision, that you wanted all those operations to be cascaded. Many developers make the mistake of putting all by laziness. Instead of, for example, enumerating two of those two, of course, of the operations that really need to be cascaded. And then they end up with someone implementing somewhere in the code another operation, and without them knowing or observing that the operation is cascaded, it's cascaded because someone set all at the level of the relationship, and they don't expect that. Setting all, first of all, cuts out a lot of your flexibility of the operations you execute with that entity, and secondly, can introduce errors because new developers then they might not observe that a specific operation that they don't expect is cascaded. So it's always recommended you do enumerate precisely the operations that you need to be cascaded. And in many cases, trust me, these operations might be only one. So for example, it might only be the persist. Okay, what about the bidirectional relationship? So I have proven here how the one directional relationship works, meaning it's only in one side, it's only one of the entities knowing about the relationship. But what about having the relationship in both? This is called a bidirectional relationship. So for example, if I want to add here the relationship to the author, so I would say the book belongs to this author, or has been written by this author, or has been authored by this author, I don't know. And I'm gonna with one-to-one again, because we started with this simplistic approach. If you have a bidirectional relationship, very important is now you manually you have to choose which is the owner of the relationship and which is not the owner. Because when you only had the relationship in one side, it was clear who is the owner of the relationship. It's normal that the owner of the relationship will always be the one defining the relationship. But now it's not clear enough because you have them in both sides. So remember, the owner of the relationship is where the foreign key is. So in my case, the owner of the relationship was the author, and it was the only one possible, and that happened because it was the only one with the relationship. But now I have the relationship in both places. Always on the opposite side of the relationship, we have to use the mapped by annotation. The mapped by annotation maps the field to which you execute the relationship. So that means book in my case. So you say this is not the owner of the relationship, and it will just be the other side mapped by the attribute book on the ownership side. Map by is always on the opposite side of the ownership, and join column, however, is an annotation that you will always see on the ownership side of the relationship, because that's where the foreign key is. So we can test that this one works. Again, you see I have no toString for the moment, and then I will also prove that thing with the toString. You will see what happens if I'm not careful with how I define a toString. So let me go back here. I'm gonna again delete the two tables. I'm gonna run them. Okay, so I'm gonna go back here and see that it worked fine. Is that it correctly worked? Oh, what happened? Didn't finish or what? Oh no, it's still running. Sorry, my mistake. I was too eager to see everything. Okay, same. Here it is. Going back, tables, refresh, and it worked fine. The only difference is at the code level. The only difference is that now you have the relationship from both sides. So that is helpful when you write queries, because you might ask, okay, and what is the difference actually? So let me try put a none here. And one of the things that you need to learn, and I'm not sure in how much detail we will get now during this event, because again, I will not be able to stay here like so many hours to discuss everything about Hibernate and JPA, but you have the playlist already, so I'm not even trying to cover everything, because I know you have a playlist there already. I'm just trying to be here with you so that you can ask the questions and start the discussions. Okay, so I'm just to be sure, I'm gonna write a query. No, and we have multiple approaches. If you've seen my playlist, you know already that I'm gonna just use the create query annotation. I'm gonna just write select B from book B, where B author ID is ID. I'm going to specify that I'm selecting a book. So this gives me a typed query for the type book. And then I'm able to set the parameter. Oh, maybe book query would be a better name. I'm going to say for parameter named ID, I want to set the value 1. Okay, so this is all the books for the author with the ID 1, which hopefully is me. And then book query get result stream for each book system out print line it. Okay, and it's one book. I deleted the two strings, so it will look ugly probably in the console. It will be something book at and then the hash code. Here it is. Okay, so this is clearly the book. Now what I wanted to prove is that I will name this query 1, or how do I, and this, anyway, no, I'm just gonna cut it out completely. But the idea is I was able to select a book by the author because the author exists in the book, and because the relationship is bidirectional, I will also be able to do the opposite. So I will be able to create the query. Let's write that from the other side. If the relationship wouldn't have been bidirectional, it wasn't possible for me to do that. So I'm now able, for example, to do the same thing, say author, select A from author A, where A book ID, giving me an author, and that's it. Yeah. But the only reason I'm able to refer from both sides is because I have a bidirectional relationship. So what's the advantage a bidirectional relationship provides me with is the ability to refer from any of the sides of the relationship. Otherwise, you in a query, you can only refer to the relationship from the side that owns the relationship. You cannot refer from the other side. So when do you choose to have a one directional relationship, and when do you choose to have a bidirectional relationship? Normally you choose to have a one directional relationship if you only need one direction. It's always easier. It's always my advice is go to the simple way possible. You don't have to put the relationship in both places if you don't need it in both places. But at the same time, if you need in your application, very often you do need in your application to have it from both places, then you need a bidirectional relationship. And then when you have a bidirectional relationship, you need to be very careful with especially referring from one another. So look what happens if I'm gonna implement the toString in both places. Now I do have a bidirectional relationship, and I'm gonna just add the toString method, uncarefully keeping the author and the book, so the relationship in both sides. And now if I'm running it, normally I should end up with Stack Overflow error, which is very common, and it happens because now I do refer from one to another, so there will be no end. Whenever the toString wants to print something, it tries to print the other instance, which go back to the previous, which goes to the other, which goes back to the previous, which goes to the other, and then of course you end up with this nice Stack Overflow. You can see it here. Yeah, it's a Stack Overflow error. So be very careful never to refer to both sides. So I can do like that. For example, I can take out the author from the book, assuming I don't need it. And the same problem, and it just happens when I printed it and with a toString. But more often than that, the same issue happens when you serialize this to send it through an endpoint, for example, as a request or a response, as a HTTP request or response. And why does that happen? Is because it's the same thing when you do that, you use Jackson or something similar to serialize, and that Jackson actually does the same thing. It goes from one entity, it tries to serialize it, and then it goes to the other entity, and then when it goes to the other, it finds also the previous, and it tries again and again and again, running into a Stack Overflow. And that happens if you decided to not only to have the bidirectional relationship, but to use the entities also as data transfer objects. And what you can do, of course, is continue using the entities as DTOs. Nothing wrong with that. Sometimes it makes sense. You remove some duplication if you do that, and if your app is small enough, maybe it really makes sense. But then you have to use some annotations on the Jackson to make it ignore one side of the relationship or the other. Or you can simply use different classes as DTOs, which is something I kind of recommend. I prefer to separate the responsibilities and have separate classes as the data transfer objects than my entities. Yeah, so be very careful with this. When you have bidirectional relationship, it's one of the things very commonly happening with your apps. Okay, and of course we can proceed and we can run our discussion further into one-to-many relationships. So now let's assume that one of the sides might have many of the others. So we can say an author may have written multiple books, but a book can only be written by an author. So if your logic is the following, then this is called a one-to-many relationship, because of course the author can have multiple books, but the books can belong to only one author. So that would be a one-to-many. So let me actually go and delete again the tables and try to recreate them using a one-directional relationship this way. So let's see what happens when we do that. Back to my application, and I will make, in this case, my author to have multiple books. We'll call them books. Okay. I will have to redo some of the things here. And of course, I can use set, list, or collection. Usually, if you don't have the application, wisest is to use the set. But for example, if you want to be a layer more abstract, you can go and use collection, because you, for example, don't know what kind of, now you want to be able to put there either sets or lists, then you can go with collection. But in our case, let's just go with the set here, and the set of book, and we need to use, so it's one author to many books. Always when you think about, because again, for beginners, I saw one of the things kind of difficult to remember is when to use. We have two annotations. Now we have one to many, and you will see later we have also the many to one. So you have to use them properly, and one to many, it's always used on a collection. But if you don't remember which one is that always used on a collection, you just go and say it from the top. Say one author has many books. No, so top to bottom, one to many, one to many. So this is one to many. Okay, here I have a one to many. Now normally if you try the many to one, it will not work anyway, because you cannot put the many to one or something on something that is not a collection. No, it doesn't make sense. This one here says that here you should have a max of one, so it cannot be a collection. So it's not a big deal when you talk about using it with IntelliJ or a different ID, a different smart ID. But it was a problem when you earlier in the days you were learning for the JPA certification. I'm not sure how many people do take that certification anymore, but back in the days it was one of the most appreciated certifications, and it was quite a difficult one because all these details you need to learn. And of course, remember, when you have a certification, you do not have an IDE, so you needed to know if the annotation you have to use is one to many or many to one, without having proper instruction from an IDE that tells you, hey, you are doing something wrong. Okay, so if you want to remember for any reason, this is always one to many. Okay, so one to many, and then this can be same as the one to one. You can go for an one directional relationship or for a bidirectional relationship. So I can leave it like this. I still need to go to the book. I'm gonna refactor it a bit as well. So I'm gonna take out, oh no, not this one. So I'm gonna take out the author. And if I took out the author here, it's clear, I hope, that this became a one directional, because I'm only from the author. I know the author has books, but I don't know that a book has an author. So from the book side, nothing is visible. So that makes now my one-to-many relationship one directional one-to-many relationship. And then I can, of course, try again to see what happens if I'm trying to put something there. So I can say author A is new author. I'm not sure why it's gray, this one for me. Oh, it's because I have, okay, and then put everything in place. So this is me, and then I have a, oh, we need a getter and a setter here for the set of books, and say I'm gonna even just put the book in advance here. So book b1 new book, b1 set title, and the type technical, and then very important, set books, set of b1, in my case the only book, yeah, but I have a set of books. And then now again, if I did set up a cascade on the relationship, I would be able to only say a persist for the author. But if I did not, which is my case here, then I have to say the persist for the book as well. So now it depends on what you want to do. In my case, let's just assume I'm gonna add here the persist. And that would work now only to persist the author. It should also persist the books. Now, very important, never forget to establish the relationship in both places. If you have on, now it's on one directional, so I don't have the author here, but we will create the bidirectional as well. And remember that it's not enough. If you have a bidirectional, it's always important to have them in both places set up. Okay, let's see how this works now. Let's clean up. Oh, I have already cleaned my tables here. Fine enough. So I'm gonna go here and I'm gonna run it. I'm gonna see what happens. I'm gonna see if the relationship properly works. Okay, something didn't work. I need to see what exactly. Demo authors doesn't exist. Yeah, sorry, I needed to put the create back here to prove that. Okay, one more try. Okay, and here it is. It creates everything. It did insert. We have to see something very interesting now. And I'm going back for that. And you will see when I refresh here that we don't have only 2 tables, but 3 of them. And I will have to explain why, because it might sound very tricky, because yeah, you probably learned that, well, it's enough to have a foreign key when you have a one-to-many relationship. No, why have a separate table, which is called also a join table in this case? So normally for a one-to-many relationship, for a one directional one-to-many relationship, if you don't specifically provide which is the foreign key, what the JPA implementation will do is create a joint table for you. So that's the way it works. That's the way it states in the specification. So what happened here, it's expected, actually expected if you know the specification. So the implementation, you saw it created the two entity tables here, and then it related everything through a separate table. Okay, fine. Here it is. But we don't want that usually, no? So that's why I started with this example, because I find it very important for you to be aware that this will happen. And what you should do is you should always define the foreign key. Now, if you want an advice from my side, I would always, in any kind of situation, specify the foreign keys and everything, honestly. So not only in this case, but I am very comfortable to put things in place and always specify everything. So in my case, join column here, name, book, and that should make everything I need. And I deleted the tables, and let me try again, see what happens with the structure now. And meanwhile, I'm gonna answer, so why do we use Flyway instead of Hibernate in real world apps? So as I was stating, and I want to say it again because maybe you are not here from the very beginning, never use this in a real world app. Never use it in a real world app. Now, I don't know how many times I should state that this is very important. Hibernate is not made to generate tables for you. It works only for examples and tutorials to save you time. But in a real world app, you have to use Flyway or Liquibase or a similar tool, because you want, first of all, to know exactly what scripts are run. You see, here you don't know. You only know if you print them in the console. And secondly, they might change depending on the version you have, and they might change depending on how you write, same as the queries we've been struggling with from the beginning. Okay, in a real world application, you want to know exactly which are the scripts that have been run, and you want to know exactly the order in which they have been run. You want to have a strong control over the structure of your database, and Hibernate is not made for that and does not provide you that. So while it is very comfortable to use this property in tutorials to make your life easier, there is a very big reason for why this is not a default, and the reason is it's not used in a real world app, because a real world app needs to have an accurate defined log of the scripts that have changed the persistent layer throughout the time. So that's why we do not use this to generate or alter the schema in real world applications. Always use something that provides you with a history of what has been changed and when, like Flyway or Liquibase. I hope that answers the question. So what's your opinion on using business values like book ISBN versus only checking IDs for the quality while implementing equals and hash code contract? I think it really matters whether it's needed or not, in terms of I never complicate things more than they need to be complex when I implement something. I would ask myself the question, is the ID enough for my equals and hash code? If the answer is yes, I would go only with that, because going with anything more, well, if it doesn't add any value, it's only over-engineering, and over-engineering is an anti-pattern that we want to avoid. So I would go with the keep it short and simple principle, the KISS principle, and I would use preferably only what really is mandatory, avoiding to use anything that doesn't bring me any value. That doesn't mean that business values like ISBN is not possible to be needed. It means that it depends on what I do, if it is needed or not, and I have to decide on the case whether I need it or not, and that I only add there anything that is a minimum of what I need to avoid overcomplicating the things. So what's the point of Hibernate if you can do everything with a script? Hibernate defines the associations and then you can use it for you working with the data. The scripts, you only use them for the DDL. That means only for the structure of the database. Flyway and Liquibase are mandatory for defining the schema, the structure of your schema, the tables, the columns, the indexes, the foreign keys, and so on and so forth. The purpose of Hibernate is working with data, inserting data, selecting data, updating data, and deleting data. So I hope that makes sense now. Okay, going back, I want to change this. So did I prove it? It now works without join table. Yes, so look at this. Now JPA knew that it can add only a join column. Of course, in a one-to-many relationship, the foreign key can't be placed in any of the sides anymore. It can only be placed on the side with many. So automatically it went into the books table because one author has many books. So that's where it goes. Okay. Good. So I went here and everything is in place, and I want now to create the bidirectional relationship as well. So going here in the author, we have the set of books, and now in the book I have to provide it with the author to have it in both sides. No, so I say author, and now it is many to one. No, again, you go from up to down. So I say book, a book has one, many books have one author. So that's how you do it. And then in the many to one, always now in the many to one, in the many to one, that will automatically, if you have it this way, will automatically define the ownership, because you are in the book, which is on the side with many. And in a many to one relationship, in a one to many or whatever, many to one, however you want to name it, as said previously, the foreign key, I deleted it, but you remember I showed you a minute ago, the foreign key can only go on the side with many. So automatically this becomes the owner. You cannot have now the owner on the other side, which means that if you have a bidirectional relationship, the join column cannot stay here anymore. So this is an exception of the rule, because in all the other situations, the join column needs to be on the ownership and only on the ownership side of the relationship. And the only reason why the join column has been here now is because if you have a one directional one-to-many relationship with the relationship on the side of the one, not the side of the many, then you don't have where to put this annotation. So now I will just put it on the right side this way. Oops. Okay. And I will always make sure that the opposite side of the ownership is marked with mapped by. So this is a must. Remember, always when it's bidirectional, on the opposite side of the relationship, you must have the mapped by attribute, while on the ownership side, you may have join column. This is not mandatory. If you don't put it, it will look like book underscore ID. We have seen this already. But remember, I did recommend you, and I do strongly still recommend you use join column to define from the code how the relationship should look like. Okay. And now we can run it again, and we can see that the result is the same, but what we ended up is having the relationship in both sides, and same as with the one-to-one that we have demonstrated previously. This helps us with queries, because now you will be able to refer to the relationship from either of the two entities. Okay, here it is. And we can see it. Here it is. Okay, cool. So someone says about using Cascade, the owner of Hibernate Red Hat. Who is Hibernate Red Hat? I'm not aware Red Hat to be owned by, I don't remember Hibernate to be owned by the Red Hat. Does not recommend using it. Well, I don't have anything against using Cascade. I actually do recommend using it. The only thing I do not recommend using is, and I did say that before, never use Cascade type all. So if you want to use Cascade, do either use directly the type or the types. If there are multiple, you can do that with a vector syntax and put all of them, but never use all. Aside for this, I don't have any other recommendation, and I'm not against using Cascade. You can use Cascade. Never had problems with Cascade. The only problem I've seen in my whole experience with Cascade is when developers, by being lazy, they used all. Okay, so this is my recommendation. Okay, and then of course we can move further, and we can even discuss about the many-to-many. Why not? Because we've been so far away within this, so we can now go to the how this relationship will actually more be the most realistic. A book might have multiple authors, an author might have written multiple books, so then it's a many-to-many. And if it is a many-to-many, I'm gonna delete them again. And then if it is a many-to-many, you don't have other options than using join tables. Now, the fun just ended. If for one-to-many relationship, you only need to have a foreign key, and for one-to-one the same. One-to-one is the most flexible, because you can even choose what is the side of the foreign key. The many-to-many doesn't allow you to use a foreign key on either of the entities. The foreign key is mandatory on a join table. So there will be a third table, but this third table, very important to remember. If we discuss about JPA and Hibernate, it's only at the database level. It will not be represented by a class at all in the code. So in my case, I could say the author has many to many. So many authors have many books, and then I can keep it like this, and I can start with this. Yes, you can have one directional relationships. Okay, so if I'm gonna use it here, let's say book, and I set the book for the author. Is the same actually, just the structure will be different here. So I can run it once it compiles, of course. Okay, I see something happens. I have a rollback exception here. Let me see if I understand why. Save transient before. I took out the cascade, isn't it? Yeah, I took out the cascade. So this is what happens if you have no cascade and you didn't either specify the persist. So I do need to do one or the other. So I either persist manually both of them, or I use cascade. Otherwise, it will not work. So I'm persisting now the book as well, and I'm restarting the app. And yeah, that's fine. And we will see three tables. So one is the authors, one is the books, and one by default name authors underline books, which is the join table. It creates the relationship between the author and the book. In my case, author number 1 has a book with the ID number 1. So both foreign keys go inside the join table. Let me show you how you change the name of the join table. It might happen that you want to apply Hibernate on an existing database. So the columns or the join table or the join columns, they don't have the default expected values by Hibernate. So you have to change them. So if you want to do that, for example, for many to many, well, if in case of the one to many and the one to one, you could have used the join column. Here we have, of course, it's called join table, the annotation. It makes sense, I guess. And then you can provide the name of the table, and you can call it differently. You can call it author book, something like that. Yeah. Anyway. So you can give it a different name. So let me run it and show it works. And then I will show you even how you can rename the foreign keys inside the table. Yeah, here it is. And then you refresh it. See, and the name is different. Name is now whatever name I chose for it. Okay. But if you go inside it, of course, you will still see that the foreign keys take their default names, which is entity underline primary key, entity underline primary key. So now I can delete all this, and I'm going to provide also custom names for the columns. So going back, I can do like that. join columns and inverse join columns. Okay, join columns is a join column with name, and then you give it whatever name you want. Inverse join column, it's a join column, and then you give it whatever name you want. So this is if you want to change not only the name of the join table, but also the name of the join columns inside the join table. And of course, you then can have a many-to-many bidirectional relationship. I can show you that as well. But then what I want to do, because I have the feeling that my voice is running down and it's already almost 3 hours and a half since we are here. And I like to talk a lot, but even I am a little bit tired after speaking for 3 hours and a half. I would like to go through the annotations that we have used and then go through the things that we have not maybe explained about them, and then maybe close this event with some advice for you. It would be awesome. And then we have a 4 hours or something like that marathon for today, which it's kind of enough for me, I would say. I know, and I knew from the beginning we cannot cover everything, but I'm pretty sure you will find more details, many more details in the playlist already that you have there. So I think this just summarizes a part of it, but I still do recommend you, of course, go through the whole playlist that we have discussed with many more details than we managed to do in this marathon event. So what I was doing here, yeah, I was proving it's working with custom column names. No, so if I'm going here, I should be able to see my custom column names. Makes sense? Good. And then, of course, I can prove that you can have also bidirectional relationship. Now, what I did here is wrong. See, I was in a hurry and I forgot to take this out. And now it's working because I'm not even sure why it's working, because probably I was lucky enough that this was scanned first. But it might have not worked at all. Never use a many-to-many on one side and a one-to-many on the other. They are not compatible. For me here, it was simply just not taken into consideration. But I simply was lucky enough to get on the case that's not taken into consideration, okay? So that's not something okay what I did here. Now, if it's a many-to-many bidirectional, I can go like this, author. And then, of course, many-to-many, sorry. And then if I decided by using join table that this is the ownership, I always need to make sure that on the opposite side I have the mapped by. And then I use the name of the attribute. And that creates for me, of course, a bidirectional many-to-many relationship. So what to remember from relationships is that it's 3 of them: one-to-one, many-to-one, and many-to-many. And each of these can be one directional or bidirectional. That my recommendation is you always use the simplest possible. So if one directional is everything you need, go for it. Not all your relationships need to be bidirectional. But remember that bidirectional relationships give you the possibility of writing queries from both sides. So if that's what you need, then you will only be able to achieve that with a bidirectional relationship. So this is a summary of the last hour, whatever, when we discussed relationships. So let me see more of your comments. Greetings from Switzerland. Greetings. Thank you very much for being here with me. And then someone, not always true that unidirectional relationship is inefficient. No, it's not true at all that an unidirectional relationship is inefficient. I don't know why you would say that. Is if you put it from one direction or the other or both directions, it doesn't make it more efficient or less efficient in terms of performance. It makes it just accessible or not for querying from a different side or the other or both. So it's a matter of design of the code, not of performance. And then avoid using one directional one-to-many because it results in unnecessary queries. Exactly. You saw actually the join table. You can mitigate that with the join column, but in most cases you would prefer to have one-to-many relationship bidirectional. So that's a very good of saying that. A little about ACID concepts and Hibernate. ACID concept is not related to Hibernate. No, it's related to relational databases. Now, while it's true that Hibernate is a technology used with relational databases, it doesn't change anything in ACID as a concept. So ACID as a concept refers to, we call it, we say a relational database is ACID, means it's atomic, consistent, isolated, and durable. And this 4 represents the characteristics of a transaction on a relational database, regardless whether it's through Hibernate used or, Hibernate is above, no? You all will have some in the end native queries that will be sent in a transaction. So in the end, that's the reason why we created a data source here in the very beginning, a normal JDBC data source, because Hibernate, it's only an ORM implementation that will end up in some native queries. Native queries we have investigated a lot during this event in some normal JDBC transactions. So there is not a lot to be said about ACID and Hibernate because the two of them have only in common the fact that they use basically common relational databases and common relational databases transactions. The ACID concept for JDBC, in other words, is the same for Hibernate and for any other high-level framework that you use that would, in the end, generate JDBC communication. Atomicity is, of course, referring to the transaction, the fact that the transaction is either committing, and that means it worked and all the operations inside all of them worked, or none of them, meaning if you have multiple changes, when you commit, they have all been committed, and if you roll back, they have all been rolled back. So you cannot have a situation where some of them are committed and some of them not. So that's the atomicity. We say that we make multiple operations atomic. They are either all of them executed or none. And then we have the consistency, which can be influenced by the isolation of the transaction, meaning how much consistent can we keep the data in the tables when we run multiple transactions at the same time. So we know that all transactions are atomic, but depending on how isolated they are for readings, we will create a higher or smaller consistency, and those consistency anomalies are called phantom reads, repeatable reads, or dirty reads. This is anomalies in consistency, in data consistency, that depend on the isolation of the transaction. The isolation of the transaction is basically what one transaction can read from another while they are executing in parallel. And for the isolation, you also have a few levels. Now you have the serializable, the repeatable read, the read committed, and the read uncommitted. And then, of course, the durability, saying that whenever something commits, it remains persistent, so it ensures persistence in the data. But all this, they will be the same regardless you are using vanilla JDBC or Hibernate. So that's everything I can say about them. Okay, and let's go a little bit through the the relationship annotations we discussed, and there are some things we haven't discussed, but maybe I can, and I will not be able to demonstrate again because it's already a long time since I'm here, and of course a marathon is always long, but I will not be able to stay forever. But I want to figure out, at least go through the essentials about this and discuss maybe from the 4 annotations that we have seen, everything that it's essential. And for example, one of the essential things we haven't discussed is the fetch type. No, so the fetch type tells you whether something is retrieved from the database when the entity is retrieved or not. And the fetch type, one of the things that we always need to know about the fetch type of a relationship is that if it is a collection, it's always lazy by default. If it is an object, it's always eager by default. That's why if I'm going in the one-to-one, if I'm searching for the one-to-one annotation here, you will see that the relationship is eager. But in the many-to-many, it's lazy. Why? Because one-to-one is always applicable on non-collection types, on simple objects, on basic object types. And basic object types by default, they are retrieved. So if I have author and book, and they have, as we had at the beginning, one-to-one relationship among them, when you retrieve an author, automatically the book will be retrieved. But if you have author with books and it is a one-to-many relationship, then you retrieve the author and by default the books will not be retrieved unless you specify precisely that you want that. And this is exactly what in some conditions may create problems, because, well, the reason it's not retrieved is because with a collection, you might have many instances on the collection side. So if you would retrieve that, if you would retrieve that by default, you might end up with situations where you go into out of memory issues and stuff like that. So the fact that on collections like many-to-many or one-to-many, no, if I'm going to one-to-many, it will be the same. One-to-many. See, it's lazy, yeah? While one-to-one and many-to-one, it's eager. Okay? Because one-to-one and many-to-one, they are both annotations that are put on non-collections, on basic objects. So basic objects are eagerly retrieved. But everything that is collection, so everything that ends in many, it's lazy. We don't want... it's on purpose, and it's very okay, it's very smart that it has been designed like that. It allows the developer to decide, hey, I know what I'm doing, I want to retrieve all those values. but by default it doesn't do that. But it also has downsides, and the downside is if you have a lazy relationship but then you want to retrieve it, you might run into an n+1 query problem. And that's something you can demonstrate. Maybe if you have a one-to-many, you find it. Let's try to have a one-to-many between author and book. No, let's say we go back to a one-to-many. So one author, many books. Okay, and then of course not right anymore. Many books, one author, something like that. Hope everything still compiles here. And let me see if I can reproduce that n+1 query problem. So that means main, have a book, and in the book I set an a set author. I need a set author for the book as well now, because I made it a bidirectional. Okay. So I'm first going to create this and persist it, and I'm gonna change the example. I know it's not really nice what I'm doing, but it's at least easier from my point of view to demonstrate that. Try to demonstrate that. Okay. So this is running now, hopefully. No? Yeah. Okay, let's make sure it looks like the way it should. Now it created me an inner join table because I forgot to put the map by. See what happens if you forget to put the map by. So the map by is important. It's a must. Remember, always when you have a many-to-many, you need to put the map by. If you don't do that, it might, and most certainly it will not recognize everything correctly. So I'm gonna delete them again and correct my definition. So this is many to one, okay, and this is the one to many. So mapped by, and I'm copying the name of the attribute. Very important. So using map by is paramount. If you forget putting it, you will end up with strange things. It's valid for any relationship, so don't forget to use the mapped by. When we have a bidirectional relationship, it's always a must to put the map by on the opposite side of the ownership of the relationship. Okay, let me see if now it looks better. Well, it does look better, of course. And now I'm gonna do it like that. I'm gonna just delete this here. Make sure this doesn't recreate the tables by putting none here. And now I'm gonna just try to find, say, Find author. The author has multiple books, no? Find author with ID 1. And then I'm gonna go through the books. I'm gonna say get books and print each of the books. Okay, I'm gonna print it. Okay, and what you see here is that we have two queries. And I know it might not look like dramatic because it's only two, no? But what happens here is that I have one query for each book this author has. Now it just happens that this author has only one book. But imagine it would have had 1000. Then you would have had here one query per each of the 1000 books. So it would have created you, in that case, 1001 queries. Why is this called an n+1 query problem? It's because you have one query at the beginning getting the entity and n more for the n records of its relationship. So if you have one author with 1000 books, you will have one author and 1000 more queries for the books. I mean n+1, n books plus 1 the author, n+1 query problem. So that's the problem with the laziness. Now, you have different ways in which you can solve that. One of them, but not the most recommended, would be to simply make this eagerly fetched. And if you make this eagerly fetched, then normally you will have from the very beginning everything. But why is this not the most recommended? Is because, of course, as I said earlier, the collection relationships being made lazily loaded is something done on purpose. You might end up then loading too many things in the memory and you will end up with memory problems. So see, yes, I do now have only one query. And that only one query would be only one even if I have 1 or 1000 books. So I solved the n+1 query problem, but in the worst way possible, because now I always get the books. And I don't want to do that either. Another option is, instead of using find, like I do here, write a query with a join. So I can simply write a JPQL that uses a join on the books, and I specify exactly through the query that I want to fetch the books as well. But then I do fetch the books only with the queries where I specifically want to fetch them. That's a better option. And the third option is use entity graphs, which we discussed actually a few days ago in the last lesson of the JPA Hibernate playlist, which I invite you to watch. So that's with the awareness on the fetching as well. So the Spring Security course, it's always updated. I don't like always update the same playlist. I do create another playlist when I think it makes sense. I would say you can learn from it now. It still contains the stuff you need. And then can you please explain the difference between unidirectional and bidirectional? Yes, of course, but this is actually, you would like to go back in this event, you will see I have detailed this quite a lot. But in a few words, because you probably missed that part, a one-directional relationship is when you have two entities, but the relationship is only defined in one of them. So for example, if I have the relationship defined here, but I do not define it here, we say that this is a one-directional relationship on the book side. Always the one-directional relationship can be on one side or the other. So you can have a one-directional relationship from the book side and the one-directional relationship from the author side. Or you can have a bidirectional relationship, meaning the relationship is from both sides. And I was explaining also a little bit earlier that the difference is mainly where you can query from. And of course, one-to-many is a special case that can create a joint table in case you define it as a one-directional. That's why we mainly prefer it to have it as a bidirectional. But as a definition, one-directional means that relationship is only from one of the sides and not from both. Bidirectional means both sides know about the relationship. Okay. So, and I was trying so discussing about the fetch type. Now we discussed about the fetch type. And cascade, or discussed map by, we discussed orphan removal and target entity, not really essential. So I think we went through the most important from this point of view. Well, I would suggest we stop because it's about almost 4 hours since we are here, and I'm very glad that actually some of you actually stayed with me the whole event, which is quite a long one. And yeah, I hope that at least I made you a good refresher of the basic things of the Hibernate. But remember that there is a playlist out there which describes many more things, and I'm looking anyway to your questions so we can discuss even more. And code review on a company and help with that. If you ask me questions, remember that I always try to answer them as good as possible. Yes, I'd be glad to help with all your questions, but remember, I will not be able to answer on specific cases. I'm going to answer on anything that's theoretical, but if you ask me, hey, how I do that in my specific application, it's not that I don't want, but it's impossible for me to provide you with a good answer. So you have to remember that any case in software development, it's unique, and there is no one solution that would fit for all. So that's why I cannot help with specific cases, but I don't think it's any one of you who can say that you haven't asked me a theoretical question and I didn't try at least to provide you with an answer in the comments or at another video or whatever. So I will do my best to help you as I did in the past years. And of course, I will close it here. I don't want to spend more time. I'm already, my voice is over, and I'm happy that I've been able to stay almost 4 hours with you here, friends. Thank you very much for staying with me. I hope you liked this event as well, and I want to say a big thank you for all of you who joined me today, even for a part of the event. I'm very happy to have seen that many of you have been here for the whole event, and of course, let's meet together again in next events. Until then, I'm gonna just say, hey, have an excellent time for learning further and stay in touch. Cheers.